The Arduino Galileo is a unique board when compared to other Arduino boards because it combines a full Linux computer with an Arduino Uno. The result is a device that combines the advantages of both worlds. Thanks to the Galileo architecture, your Arduino sketches can take advantage of any program that runs on the Linux side. Your sketches can use operating system commands or programs written in powerful languages such as C, Python, and Node.js. The Arduino Galileo Generation 2 board comes with several peripherals built in, saving you from the expense of things like an Ethernet shield, an SD card module, or a real-time counter. It also comes equipped with a USB host port for connecting a keyboard and mouse, and a second serial port that gives you direct access to Linux. All these features allow you to use all of the Uno-style header pins for digital input and output instead of occupying them for the peripherals. In this lecture, I will introduce the Arduino Galileo Generation 2. Let's begin. Hi. In the lectures in this section, I'll be discussing the Arduino Galileo Generation 2, a fairly unique board when compared to the other Arduino boards. It is essentially a computer that has an extension on the board that is compatible with Arduino shields and with the Arduino pinout, so that you can connect Arduino compatible sensors and components and breakouts and shields. There's also support with the Arduino IDE and libraries that allow you to control or to access the various features that the board offers, such as, for example, the integrated Ethernet port. There's integrated mini SD card slot, and at the back we also have a mini PCI slot that can accept Wi-Fi module that is also accessible through the Arduino side of the board. In this lecture, I'll give you the rundown on the features of this board, and then starting with the next lecture, we'll set up the board and start doing some Arduino related experiments, and also look at how the Arduino side connects to the Linux side and how you can use it through Arduino sketches. Looking at the Intel Galileo datasheet, this particular datasheet is written for the original Galileo, but its features are the same, pretty much the same as in the Galileo Generation 2. The processor, for example, hasn't changed. We can see that at the core of the board, we've got an Intel Quark system on a chip X1000 application processor. This processor runs the Linux operating system and the sketches for the Arduino side. It's a 32-bit Pentium class system on a chip processor. Intel designed this chip so that its input-output pins are directly compatible with those of the Arduino. So first of all, you can see that the headers between an Arduino Galileo Generation 2 and Generation 1 and those of the Arduino Uno are compatible. So there are a lot of shields that will be directly supported on the Galileo Generation 2. As far as the voltages are concerned, the Galileo Generation 2 allows you to connect 3.3 volt and 5 volt shields. So at least from a voltage point of view, there is no problem at all to connect Arduino Uno style shields. The only question is whether the libraries will support it, because of the architectural differences between the Galileo and the Uno. Not all libraries are compatible with the Galileo. I'll show you a few examples later where you see that in order, for example, to use the Ethernet port that comes with the Galileo, we'll need to use specific Ethernet libraries that are designed for the Galileo. Same thing goes, of course, with the SD card. So there are changes in terms of the software that the Galileo can use when compared to the Uno. When you have a closer look at the shields and the pinouts on the shield side, we'll see that they are all exactly compatible with the Uno. So we've got the transmit receive for the serial port, and we've got the digital pins. Several of these support PWM. On the other side, you've got the power header here, which supports the 3.3 and 5 volt pins. We've got ground, VN as well. There's a marking here for the IO ref, but this pin actually is, even though it is broken out, it's not supported, so you can't have a voltage reference supplied to the Arduino Galileo A1 affect the analog input readings at all. There's also the usual analog pins. There's 5 analog pins, analog pin ins. There is an ISP header for SPI communication, so I'll be using this header here later to connect an external display, a color display. We've got an I2C bus broken out to pins A4 and A5, but there's also another 2 dedicated pins for the I2C here. You can see SDA and SCL. So those are broken out. You can either use the A4 and A5 pins or the 2 broken out pins here for I2C. I'm also going to be using this as in an example later on. The Galileo has integrated 100 megabits per second Ethernet port that is accessible from the Arduino side using a specially designed library that I'll be using and demonstrating later. There is a mini SD card slot that can accept large SD cards. I'll be using a 32 gigabyte SD card in here to store a full version of the operating system, of the Linux operating system. That gives me access to things such as Wi-Fi support and Python interpreter and things of that sort. A very interesting feature is this header here. So this header here allows me to connect a serial interface, a serial to USB interface, and interact with Linux directly. I'll be using this feature a lot in the next few lectures. We also have 2 USB ports. So we've got a client USB port and a host USB port. So you can use this USB port here to connect a mouse and a keyboard to your Arduino Galileo and therefore control the Linux operating system with a directly plugged in keyboard and mouse instead of having to go through another external computer and then connect it via the serial ports. There's also a USB client, and we'll be using the USB client to upload sketches to the Arduino for execution. So this one is the equivalent of the programming port on the Arduino Zero or the Duo as an example. The board has got 2 buttons. The first one is the reset button, this one here. So if you press this button, it will reset the Arduino sketch that is running on the board and restart it. Whereas if you press on the reboot button, this will restart the whole Linux operating system and of course the sketch that is controlled by it. The microprocessor also has a real-time counter that can be used to maintain true time and date, and there's a breakout of a coin battery to power that real-time counter here. So if you want to use the Intel Galileo in a battery powered application, they can plug coin battery power to these 2 leads and they will allow the Arduino to maintain time and date. Quick focus on the processor itself. So apologies for the cable tie. I've got this cable tie here in order to keep in place the mini PCI a Wi-Fi module that I'll be plugging into this slot later. So I've got the cable tie to do that. Not very professional, but it works. So let's focus on the processor for a minute. So this processor runs at 400 megahertz. It's a 32-bit architecture. It's got 16 kilobytes of level 1 cache and half a megabyte of static RAM on the board. There is an SPI flash chip on board that allows you to store a small version of the operating system that fits within 8 megabytes. Not very capable, so we're not going to be using it much. We're just going to boot in it for the first time to make sure that it works, and we'll upgrade it. But there is an 8 megabyte flash, and also the same flash is used to store the sketch, the last sketch that is executing on the board. On the chip, we also have half a megabyte of static RAM, and we also have 256 megabytes of dynamic RAM, these two chips. And finally, the board also has 11 kilobytes of EEPROM that is programmable via the EEPROM library from the Arduino side. For power, when you buy an Intel Galileo, you also get a power brick like this. So we power the Galileo from the barrel adapter. According to the instructions, the boot up sequence involves first plugging power to the Galileo through the barrel connector, letting it boot, and then connecting the USB client and onto the computer. I've heard people saying that you can actually damage the board if you connect your computer to the board via the USB client port first and then provide power. I don't know how true that is, because accidentally I've done that. There was no damage. So I'm not sure, but just to be on the safe side, I would follow the Intel prescribed recommendations and provide power, turn the board on. Once it finishes booting, connect your computer and start the Arduino side programming. This section is interesting from the datasheet. It gives us some information on the properties of each pin on the board. So each pin has the ability to source, so to give out up to 10 milliamps of current and to receive up to 25 milliamps of current. The digital pins combined, so out of all these pins at the same time, they can provide up to 40 milliamps of current, and they can sync up to 100 milliamps of current. You've got the same setup for the digital pins, so all of the digital pins together at one time can provide a maximum of 40 milliamps. I'll switch now to my Arduino boards comparison just to have a quick look at how the Galileo compares to a couple of other boards that we've looked so far. So for example, against the Uno, obviously a completely different architecture. The Galileo Generation 2 is running a full Linux operating system. It's got a full 32-bit processor. Electrically, the Arduino Uno and the Galileo Generation 2 are compatible, so we can plug in Uno-style shields without fear of causing damage. Electrically are very similar in terms of the total number of broken out input and output pins. They are the same. Memory wise, the Galileo has got a lot more available memory for your Arduino sketches. It's also much faster at 400 megahertz. It's a larger board as well. There's a real-time counter. There is no onboard debugger, but there is a JTAG slot at the back of the board. So there is a JTAG board that you can use for debugging your applications. And there's a bunch of integrated peripherals, such as an integrated SD card slot. There's native USB, a mini PCI usually used for the Wi-Fi module. There's also power over the Ethernet, so you can plug in a power over the Ethernet cable to the Ethernet connector, and they will provide power to the board instead of using the power barrel connector. A quick look at the schematic that's also available in the datasheet. So we've got the processor in the middle. It breaks out the Arduino compatible pins to the Arduino compatible headers. We've got the ICSP header, which is found at the same location as in the Arduino Uno table. We've got the two dynamic RAM chips that give us a total of 256 megabytes, mini PCIe slot, micro SD controller. We've got the two USB ports down here, client and host. Client is the equivalent of the programming port on the Arduino 101, and the 10100 megabits per second Ethernet port. In the original Arduino Galileo, instead of having a nicely broken out serial port like you get in the Galileo 2, instead you had an audio style jack. So an audio style jack, not an audio jack, out of which you get an RS-232 signal. So it looks like this connector here. So that required a specially constructed cable to be able to convert this port into something that you can plug into the USB port of your computer and then access the RS-232 signal from that. So that was a real pain, and luckily Intel changed it in the second generation of the Galileo board. Okay, we'll stop the introduction here and we'll move on to the next lecture, where I'll boot the Galileo using the Linux version that is in the integrated 8 megabytes of flash, show you how to upgrade it to the latest version 1.04 at this time. And once that is done, make sure everything works, we will set up an SD card with a full operating system and then boot into that.